Hi everyone. Today we're going to study rational numbers and their decimal expansions. By definition, a rational number is a number of the form P over Q, where P and Q are integers and Q not equal to 0. The decimal expansion of P over Q is terminating or non-terminating repeating. In some books, they use the word recurring. Let us see this theorem. Let x be a rational number whose decimal expansion terminates. Then x can be expressed in the form P over Q, where P and Q are coprime and the prime factorization of Q is of the form 2 raised to n times 5 raised to m. We call this powers of 10, where n, m are non-negative integers. Example 1. Convert 0.375 into fraction and simplify. The given decimal is 0.375. We read this formally as 375 thousandths. We include here the placed value of the last digit, which is 5, the thousands. By this, we express our decimal as a fraction, just like this. In the numerator, we copy the given decimal without the decimal point. So we have here 375 over 1000, because we have here thousands as the place value of the last digit, which is 5. And then let us express the 1000 into 10 raised to 3. In the next step, we're going to list the prime factorization of both numerator and denominator. In the numerator, we have 3 times 5 cubed. In the denominator, we have 2 times 5, and the quantity is raised to power 3. And then, let us distribute the power 3 of the denominator to each of the factor. So we have 2 cubed times 5 cubed. Next step, let us cancel out common factors and simplify. The 5 cubed is common, so we cancel it out. So in the numerator, we have 3 times 1. So we have 3 over the 2 cubed becomes 8. This is the final answer. Example 2. Convert 23.3408 into fraction and simplify. The given decimal is here, and we read this formally as 23 and 3,408. The place value is 10,000. So we write this as a fraction. In the numerator, we copy our decimal without the decimal point over the 10,000 value, which is coming from the placed value of the last digit, which is 8. And then, let us express our denominator into 10 raised to 4. In the next step, we're going to list the prime factorization of both numerator and denominator. For the numerator, we have this 2 raised to 6 times 7 times 521 over, in the denominator, this 10 raised to 4 becomes 2 raised to 4 times 5 raised to 4. Then, we're going to cancel common factors. The 2 raised to 4 in the denominator is cancelled totally, and there is 2 raised to 6 in the numerator. Cancelling the 2 raised to 4, we have 2 squared that remains in the numerator times the 7 times the 521. So we simplify the numerator as 14,588 over the 5 raised to 4 is equal to 625. This is the final answer. Let us see the other theorem. Let x equals p over q be a rational number such that the prime factorization of q is of the form 2 raised to n times 5 raised to m, or we say power of 10, where n and m are non-negative integers. Then x has a decimal expansion which terminates. This is the reverse process of what we did in the first two examples. Let's have example 3. Convert 13 over 125 into decimal. The given fraction is 13 over 125. We're going to list the prime factorization of the denominator, and that is 5 cubed. Next step, we're going to convert the denominator into powers of 10. The form is 2 raised to m times 5 raised to m. Take note here that we must make the powers equal. In our denominator here, we have 5 cubed. Thus, we need a factor 2, but with the same power, that is 3. So, we multiply the 5 cubed by 2 cubed. Since we multiply our denominator by this value, same value must be multiplied to the numerator. So here it is. Then let us simplify our denominator into the quantity 2 times 5 that is raised to power 3. And then the 2 times 5 becomes 10 that is raised to 3. Simplifying further, the numerator becomes 13 times 2 cubed is 104. The 10 cubed is 1000. Now we are ready to convert this fraction into decimal. For the decimal value, this is what we will do. In the numerator value, we're going to move the decimal point to the left into number of places as there are zeros in the denominator. Our denominator is 1000. So we have here 3 zeros. Our numerator is 104. The decimal point is after the number 4. So we're going to move the decimal point 3 places to the left. So the decimal will be like this, 0.104. This is the final answer. Example 4. Convert 7 over 80 into decimal. Our fraction is 7 over 80. First thing to do is to list the prime factorization of the denominator. 80 equals 2 raised to 4 times 5. Next is, we're going to convert the denominator into powers of 10. Again, we say that the powers, that is m, must be same. There must be two factors, 2 and 5. And here they are. We can see that the power of 2 is 4, while the power of 5 is 1. The power of 2 is more. We need to adjust to the factor 5. So we are going to multiply the denominator by 5 cubed so that the power of 5 will be equal to the power of 2, which is number 4. Now we multiply our denominator by 5 cubed. It means we should multiply 5 cubed to numerator also. So it becomes like this. When we simplify the denominator, we have now 2 raised to 4 times 5 raised to 4. In the numerator, we have now 7 times 5 cubed is 125. Then we simplify further our denominator. It becomes 2 times 5 and the quantity is raised to power 4. In the numerator, 7 times 125 is 875. The 2 times 5 here becomes 10, that is raised to 4. Simplifying this 10 raised to 4, we have now 10,000. So we have the fraction 875 over 10,000. We are now ready to write this as decimal. For the decimal value, look at the numerator. We're going to move the decimal point to the left into number of places as there are zeros in the denominator. We have 10,000 in the denominator. It means 4 zeros. We're going to move the decimal point of the numerator value 4 places to the left. So the decimal is 0.0875. This is the final answer. Here is another theorem. Let x equals p over q, where p and q are coprimes, be a rational number, such that the prime factorization of q is not of the form 2 raised to n times 5 raised to m, where n, m are non-negative integers. Then x has a decimal expansion, which is non-terminating repeating. Again, in some books, they use the word recurring. Example 5. Convert 1 over 7 into decimal. We can see that our denominator, which is the number 7, is clearly not of the form 2 raised to n times 5 raised to m. Thus, it will not have a terminating decimal. Let us now divide 1 by 7. So, here we go. 1 divided by 7 cannot be. So, we write 0 on top of 1. Then we show the decimal point after 1. That same decimal point we will put after 0 on top in the quotient. Then we will add 0 to 1. This becomes 10. 10 divided by 7 is 1. 1 times 7 is 7. 10 minus 7 is now 3. Then we add 0. 30 divided by 7 is 4. 4 times 7 is 28. 30 minus 28 is 2. Then add another 0. 20 divided by 7 is 2. 2 times 7 is 14. 20 minus 14 is 6. Then we add another 0. 60 divided by 7 is 8. 8 times 7 is 56. 60 minus 56 is 4. Then we add 0. 40 divided by 7 is 5. 5 times 7 is 35. 40 minus 35 is 5. Then we add 0. 50 divided by 7 is 7. 7 times 7 is 49. 50 minus 49 is 1. Then we add 0. 10 divided by 7 is 1. 1 times 7 is 7. 10 minus 7 is 3. Then we add 0. Then we pause in here. Check now that remainders are 3, 2, 6, 4, 5, 1, 3, 2, 6, 4, 5, 1, and so on. Remainders repeat after a certain stage. So, we will have the block of digits 1, 4, 2, 8, 5, 7 repeating also. So, this is the final answer.